first thing we should do is, class, is there a greatest common factor? Notice the first three terms have an x, but this last one does not, so we do not have a greatest common factor of an x. Notice I have 1, 9, 11, and 21. They have no common factors. So in this problem, I can't use the GCF. Well, obviously, count with me how many terms? Class, this is a binomial. So it's not a binomial. Is it a trinomial? Okay, now if it has 4 terms, can we factor by grouping? Although you can take a greatest common factor here, this one does not have a GCF. So I can't factor by grouping. We're going to have to do the last one, which is what? Rational roots theorem. Let's do that. Everyone say last term. Let's get our last term. Our last term is 21. Last. Our answers are 1 times 21. What other numbers multiply to be 21? 3 and 7. Any other numbers multiply to be 21? What's our first term, class? It's a 1. Class, what's the only factors of 1? Is 1. So there, I'm just taking my last divided by my first. You might be asking what's happening here. Here, you're going to have both positive and negative. All of the options we're going to have are both positive and negative. So we found the first and last terms. Let's divide these. What's 1 divided by 1? 1. 3 divided by 1? 7 divided by 1? And 21 divided by 1. These are all the positives. And then what's the negatives? Negative 1, negative 3, negative 7, and negative 21. These are all of my combinations, and I need to test them. Combos, we need to test. Okay, we divided them. Now we have to cross off any duplicates. Now there's no duplicates on here. There's a positive and negative, but that's not a duplicate. A duplicate might be something like 3, and then you might see another 3 down here. All right, the next thing we're going to do is we're going to test them. We have 8 to test, and when you see this list here, first eliminate fractions. Okay, fractions are not easy to work with, so I would not recommend it. The second thing I would avoid is the bigger numbers, so I would start over here with 1 and negative 1. Let's try using a positive one. Let's see what happens. Class, what would I put here? A 1. What are my coefficients? 1, negative 9, 11, and 21. This comes down. What goes here? Multiply. Add. Multiply. Add. Multiply. Add. Class, is this a factor? Not a factor. That means when x is equal to 1, it does not produce a factor, so I'm going to put a little red X above that. Let's test -1. Class, what number do I write here? -1. Coefficients? Bring it down. Multiply. Add. Multiply. Add. Multiply. Add. By the factor theorem, what does that tell us? -1 is a factor. Okay? Watch what happens next. Same thing we did in our warm-up. Class, what binomial can I put here? X minus 1 or x plus 1? X plus 1. Remember, if you get confused on that, make it set equal to x. You're making this set equal to 0, so I would have to add 1 to both sides. And that's why the binomial is x plus 1. Question. What does the 1, -10, and 21 represent? 1x squared, or just x squared, -10x, and this one represents 21. Remember, this is your remainder, this is your constant, and you just work your way up. Okay? Okay. Not done yet. Ask me to factor completely. I'm going to have to factor this one. A times C. B value. -10. Partner B tell partner A, two numbers that multiply to be 21 but add to be -10. Ready, set, go. Thomas, for two numbers. -7 and these multiply to be positive 21, add to be -10. So if we factor here in yellow, it becomes these binomials, and this is our final answer. To review, I had 4 terms. I couldn't factor by grouping, couldn't find a GCF, couldn't even use the Xbox. We used something called the rational roots theorem. Take your last and your first factors, and you're testing them. If it's not equal to 0, it's not a factor, choose something else. We chose -1. It gives me a remainder of 0, so this is a factor. That means in synthetic division, you can use this to write your trinomial and factor again.